Well, hello and welcome. In this presentation, I will be looking at reducing balance depreciation and how this can be modelled using recurrence relations. Now, reducing balance depreciation is effectively where we consider the value of our asset to depreciate in a non-linear fashion. It will do most of its depreciation in the first years of its service, and then as it gets older it will depreciate less. It can be modelled using the geometric decay rule, which is effectively R or Vn equals R to the power of n multiplied by V0, where R is a number less than 1. So consider this situation here. Say I start with the number 1000 and I continually multiply it by 0.8. What you'll notice, the number will decrease the most in this first iteration, and it will keep reducing and approach 0 but never quite get to 0. We will have an initial value of this sequence of being 1000 and a rule to find the next value is basically multiplying by 0.8. So we could say for this recurrence relation, our next value will be our current value multiplied by 0.8. And the recurrence rule is Vn equals 0.8 to the power of n multiplied by 1000. Okay, example 1. Harrison's $2,000 bike depreciates at a rate of 20% of its current value every year. What will Harrison's bike be valued at after 5 years? Okay. Whenever I see words such as depreciate and current value, straight away I'm thinking of reducing balance depreciation. What this tells me is that his bike, after 1 year, has lost 20% of its value, or in essence it's worth 80% of its value after 1 year. So 80% of the 2000 will be what it's worth after the first year. The second year will be 80% of what it was worth after the first year, and so on and so forth. Now I'll look to solve this using a recurrence rule. So the initial value is 2000. Now my rate is 0.8. My R is 0.8. Now the way that was derived is 1 minus the 20%. In other words, it's lost 20% of its value. Now to solve this effectively, my value after the 5 years will be 0.8 to the power of 5 multiplied by 2000. In other words, it's worth $327.68. So it's lost a lot of value in its 5 years of use. Okay, we'll move on to Harrison's mate Bowen. Okay, example 2. Bowen's car depreciates at 20% of its current value every month. If Bowen's car is currently valued at $25,000, calculate the value of Bowen's car 1 year earlier. Now what this is really saying, his car started off with some value which we don't know, and we've multiplied it by 0.8, and it's been multiplied by 0.8 and 0.8 and 0.8 for 12 months. and it's ended up with a value of $25,000. We want to know what was its original value, its initial value. So that basically is my unknown. I know my value of R is 0.8, and I know my value after the 12 months is 25,000. So what I need to do is go back to my recurrence rule. My Vn equals Rn to the power of V0. So in other words, my Vn, my V12 is 25,000 equals 0.8 to the power of 12 times my initial value. So I can either just perform that straight calculation here on my calculator, and I end up with 36,378. If this is getting a little bit scary for you with the algebra, then you can look to solve for V, where I've said 25,000 equals 0.8 to the power of 12 times V, and I want to solve for V. So there you have it. Two examples demonstrating the reducing balance depreciation method. So until next time, good maths, and bye for now.